Hello. Am I audible?
Yes, Professor.
Yeah, I just wanted to check that.
Yes, sir.
And video is also okay?
Yes, Professor.
Okay, thank you. Do you want me to try the share screen now, or it's okay? We can just start later on.
We can start later on, sir. Now, for the 10 minutes, for the next 10 minutes, we'll be playing videos on
Okay.
of global engagement and
Okay.
videos specific to AARDO and IITM.
Okay, sure. Okay.
So I'm using sir for 2 minutes on it. Camera is on, sir. Hello, Mr. Chair. Am I audible?
Yes, sir, you are audible, sir.
Okay. Hi, Ujjwala ji. Good afternoon. Your voice is mute. Your mic is mute.
Good afternoon.
Good afternoon.
Ujjwala ji, I'm just configuring as a Secretary General lab that desktop. So that picture and voice is clear. Thank you.
Sure.
Am I audible?
Are the first startup in India that is working on an indigenously developed microgas turbine.
Other applications like running cars or generators, they have been impractical and expensive. Even when in theory, gas turbines offer more efficiency and are fuel independent.
There are now materials that is much more cheaper than the manufacturing methods, which are so cost effective, and the advancement like 3D printing can make small gas turbines possible today in this world. System is derived from the aircraft engine and is going to be extremely reliable, and the maintenance or the service cost will be close to zero, and this will augment extremely cheap power for the end user.
The only thing that you have to know is the location of library. This quote by Albert Einstein powerfully drives home the importance of library.
There are many hard copy lovers in the industry, so we can find many hard copies in the library, the books recommended by the professors, or any novels or any books that you want.
Two things I like about our library is DKC and online facilities. Like we have access to a lot of online journals here, and that's very useful for a researcher like us. A lot of undergraduate students do not have laptops with them when they come here, so they can have access to computers. So in that way, I think our library is quite good.
One of the best facilities that the library offers is the OPEC system. The arrangement system is also very well organized so that it's not hard to find the books that you need.
And sometimes I forget I'm in Chennai. The place is very quiet actually. Another part that I like about this thing is that I could borrow as 10 books at a time. I can actually get these books renewed through online, and we could actually give a request for new books. It's quite effective. So I'm having a good time in the library.
Actually, we have a very good world-class gym facility with standards for everything, like for cardio, high-intensity training, weight training, Tabata workout, everything here.
Sporting culture here is one of the best in the city, and we have great facilities.
What I find is the facilities here which we have got is really good.
And the facility that we have to practice our own table tennis game.
The coaches are really friendly, they are really experienced, and
it's a place where you can play without any selfishness.
This powerhouse where the foremost innovators entrepreneurs of the country team up with the smartest talent pool of students and faculty from IITM. The Research Park plays a catalyst that fuels unrestrained networking for future growth and business success while solving globally relevant problems. Space plays a vital role for business communities in shaping company culture. In the landscape of a thriving economy, the Research Park is located in the heart of the tech corridor in Chennai, lending homegrown expertise for global solutions. IIT Madras Research Park, the future of cutting-edge research and development.
Majority of students up in many colleges across the country, and quality varies a lot. From college to college. What should a premier educational institution like IIT Madras be doing? And NPTEL is an answer to that.
NPTEL is an online courses or a MOOCs platform
the largest repositories of engineering content in the world.
Type of students that we are able to reach is a fairly broad spectrum which goes into this idea of lifelong learning.
NPTEL with the local chapters is actually a very collaborative environment in which we want to cooperate and work with the colleges rather than being a competition for them.
Wherever you are, whoever you are, if you're interested, you can learn.
Technology technology plays
A very good afternoon, everyone. We also have global audience across the globe in different time zones. I, Ujwala K, the coordinator of SIDDHI, the technology dissemination platform on sustainable and rural development at IIT Madras, welcome you all to this event. May I request our tech coordinator, Mr. Rudra, to play a short video that we have made for the program.
Technology plays an important role in the socio-economic transformation of the developing countries. Protection and enhancement of natural, physical, and human resources through a judicious technology plays an important role in the socio-economic transformation of the developing countries. Protection and enhancement of natural, physical, and human resources through a judicious application of technology is essential to create a long-term impact to improve sustainable livelihoods in the rural areas. Technology-based interventions can aid the development of notably micro, small, and medium-scale enterprises in rural areas. Bottlenecks faced during the various stages of technology development, transfer, and dissemination would be discussed, and problems will be identified to develop solutions based on the requirements of the end users. Against this backdrop, IIT Madras, in collaboration with African Asian Rural Development Organization (AARDO), takes pride in conducting an e-training program that showcases selected technologies, solutions, and approaches developed in collaboration with its partner institutions, with a special focus on technologies for the rural areas and their livelihoods, access to value chains and markets. Team SIDDHI, the technology and sustainable development platform of IIT Madras, with an emphasis on social relevance and global impact, takes immense pleasure in inviting the participants to this grand inaugural event. Let's join hands to transform lives in rural areas for the better.
Thank you, Mr. Rudra. We welcome our global audience in this program on behalf of AARDO and IITM. We have with us policymakers, senior level executives from government departments, ministries, agriculture engineers, scientists, researchers engaged in policy formulation and implementation, planning and appraisals from AARDO member countries. The theme of the program is rural development and agriculture, agri-technology, small, micro, and medium-scale business, sustainable eco-friendly startups, social entrepreneurship, and women-run and owned business. We are extremely privileged to welcome His Excellency Dr. Manoj Nardio Singh, Secretary General of AARDO. We also welcome Professor Bhaskar Ramamurthy, Director of IIT Madras, Professor Raghunathan Rangaswamy, Dean of Global Engagement, IIT Madras, Professor Abhijit Deshpande, Professor in Department of Chemical Engineering, and Professor in Charge, Rural Technology Action Group at IIT Madras. We are also honored to welcome Mr. Paul Mahal, Founder CEO of Stanford Ventures, California, USA. We welcome all the participants from Asia and Africa. We thank all the participants in this 8-day e-training program on a panorama of affordable and innovative technologies and solutions for rural development. We would like to know your feedback and inputs on how to make this program more accessible and convenient for you. We look forward for a great event. Once again, we thank His Excellency Dr. Manoj Nardio Singh, Secretary General of AARDO, and AARDO executives for collaborating with IIT Madras. May I now request Professor Raghunathan Rangaswamy, Dean of Global Engagement, IIT Madras, to speak about Siddhi, AARDO, and future vision.
Thank you, Ujwala. Welcome to everyone. I just wanted to say that Siddhi was started in response to a GOI circular asking institutes to commemorate Mahatma Gandhi's 50th year birth anniversary. The intent was to run webinars with our international partners, also through a GOI initiative called Spark. We at IIT Madras wanted to do something more than just a few webinars, and hence conceptualize Siddhi from 3 viewpoints. One of the viewpoints was to really retain Mahatma Gandhi's social consciousness. Second was that since IIT Madras is one of the top technological institutions in India, the second vantage point was to look at how technology could serve society. Of course, finally, we also wanted to embrace a pan-global context and audience. As a result, every one of the webinars that we have conducted have all of these 3 components. And this is exemplified by this particular workshop in collaboration with AARDO, where we have participants from a number of countries in a topic that is of real social relevance. And all the webinars are towards how technology developed at IIT Madras with our partners can help. So this really exemplifies what we are aiming for. It really provides us immense satisfaction that we could do this in such a short time. We started Siddhi in August last year. And if someone had told me that we would be running this e-training in 6 to 7 months, I would not have believed it. So I think it's incredible hard work of the Siddhi group here at IIT Madras that made this possible. So I welcome all of you, and I hope this e-training provides you food for thought. And also, hopefully, going forward, we will be able to actualize some of these and implement some of these technologies through technology transfer agreements. Thank you very much.
Thank you, Professor Raghunathan. May I now request Mr. Paul Mahal, Founder, CEO of Stanford Ventures, California, USA, to speak a few words on global technologies and rural development. Over to you, sir.
Good morning, members of the AARDO and IIT organization. We would like to thank His Excellency for this initiative where technology inclusion for accelerating the impact in rural development has been started by him in AARDO for member countries, for building partnership for the sustainability of this model to be deployed across member countries. We would like to thank IIT management in partnership with AARDO organizations in this most relevant capacity building program at different levels. We at Silicon Valley are working very closely with many member countries and exerting technology from all over the world for growth of rural economic and building livelihood for many. And we are here for about 50 years, and it's our pleasure to work with both AARDO and IIT in bringing technology that will be meaningful to any and every country around the globe. And we thank you for including us. Thanks so much.
Thank you, sir. We are honored to have you as a guest today. May I now request Professor Bhaskar Ramamurthy, Director, IIT Madras, to speak about IITM's contribution to rural development and social entrepreneurship.
Thank you very much. And a very good day to all those who are part of this inauguration of the AARDO-IIT Madras e-training program on a panorama of affordable, innovative technologies and solutions for rural development. I'm delighted to be a part of this inaugural program. And let me say that at IIT Madras, a large cross-section of our faculty and students have a deep and abiding interest in providing innovative solutions using new technologies wherever relevant, and new reworked technologies from the past for as solutions for problems that are faced by our rural population, both in their occupations, from farming to all kinds of other artisanal occupations, to their ease of living in the home and in their civic surroundings. So our rural areas in all these countries, definitely in India, but I'm sure in the countries of Asia and Africa, are faced with very different types of challenges. I'm sure, and there's a fair amount of good amount of understanding, I would say, and knowledge among the rural population on what can be done, what needs to be done. And we are very aware that no one solution will fit all and can be applied in a routine manner across geographies and continents. So our faculty and students work on specific challenges or problems that are brought to their attention. And sometimes the solutions they come up with turn out to be useful, and sometimes they turn out to be not quite up to the mark, as in any endeavor involving research and development. So they've had quite a few successes in finding good solutions to problems that were brought to their notice. And this has also led in some cases to entrepreneurship, because to implement a solution, one needed an organization, a company, to actually take the solution, scale it up, and make it available across the rural areas where it is useful. So these types of entrepreneurial efforts are quite dissimilar to typical startups, in that they have long gestation periods, they need hand-holding. So
No voice, madam.
Sir, we request the audience to wait for a minute. We're trying to get Professor Bhaskar Ramamurthy back on the audio. Please give us a minute.
Can you hear me now?
Yes,
Yes, we can hear.
Yes, sir. I'm
Yes,
sorry,
we
I
can
got
hear.
Yes,
I got bumped off for a brief while. I didn't have much else to say. I wanted to make only one point that we are aware that there are no one size fit all solutions. So the best thing one can do is to share experience, share knowledge. So this training.
Sorry, there seems to be.
Yes, there seems to be some problem. I request everybody to kindly wait for a moment, please. Professor will be back very soon. Just have some patience.
Okay, thank you, Dr.
Kindly requested. Ujjwala ji, can you hear me?
Yes, Dr. Dayal. I think we'll go with the flow of the agenda.
Yes, that we can proceed further as per the program schedule. Also. This
Sure,
is my
sir. Sure, sir. May I now request Professor Abhijit Deshpande, Professor, Department of Chemical Engineering and Professor in charge of Rural Technology Action Group at IIT Madras, to introduce His Excellency Dr. Manoj Nadeo Singh, Secretary General of AARDO.
Thank you very much, Ujjwala. A very good morning, good afternoon, or good evening to all of you. It's my pleasure to be part of this event, in which we hope that we will evaluate, we will look at various options available in terms of technology, and we will also see the future in terms of collaborations as we start. It is my great pleasure to introduce Dr. Manoj Nadeo Singh, who hails from Mauritius, and he's took over the charge of the Office of Secretary General of AARDO since 2019, after having been elected by the special session of AARDO Executive Committee. Before his being the Secretary General, he has served several leadership and policy positions within AARDO as well as Government of Mauritius. And his multifaceted experience also includes a professorship of economics. We being from the academic world see that he has keen academic interest, because of which he's continuing to deliver lectures on several topical themes, and he's also guided management students in Mauritius. His academic journey began in Finance Academy in Moscow with research on modeling of organizational and methodological and instrumental support for small organizations. His Excellency's focus has been on cooperative development programs, planning and development, regional cooperation, and themes which are very much relevant for a lot of what we may be discussing during this training program. And because of his overall leadership roles, he has interacted with several international organizations such as International Labour Organization and UNDP, among others. His Excellency has been also board member for Farmer Service Cooperation, Irrigation Authority, Court of University of Mauritius, and National Institute of Cooperative Entrepreneurship. So with this, again, I welcome all of you and give an special welcoming salute to His Excellency Dr. Manoj Nadev Singh. Welcome, sir.
Thank you, Professor Abhijit. May I now request His Excellency Dr. Manoj Nadev Singh, Secretary General of AARDO, our chief guest of today's program, to speak a few words on AARDO.
Thank you, Madam. Respected Professor Bhaskar Ramamurthy, Director, IIT Madras. We were getting your message very clearly. Professor Raghunathan Rangwasamy, Dean of Global Engagement, IIT Madras. Professor Abhijit Deshpande, Professor of Department of Chemical Engineering, in charge also of RUTAG. Mr. Paul Maher, Founder and CEO of Stanford Venture. Mrs. Ujjwala, Lead Program Administrator and Coordinator, CD. Distinguished faculty members and eminent resource persons. My dear colleagues, Mr. Anwar, Dr. Dayal, Mr. Kamal, and heads of departments of AARDO and colleagues of AARDO, and colleagues of IIT Madras, dear participants, all other protocols respected, ladies and gentlemen, a very good day to you all. As Secretary General of AARDO, it is an immense pleasure for me to greet you on behalf of 31 governments and to welcome you at the inauguration of our online international training program on a panorama of affordable, innovative technologies and solutions for rural development, which is jointly being organized by AARDO and IIT Madras, one of the prestigious institutions par excellence in India. At the very outset, I wish to express my sincere gratitude and profound thanks to Professor Bhaskar Ramamurthy, Director, IIT Madras, and his dedicated team for kind support and cooperation and professionally managing the program. Having with us 125 registered participants from 25 countries is very, very encouraging. And indeed, it is a testimony of the importance of transferring appropriate technology to the rural areas of the countries from where these participants are coming from. Ladies and gentlemen, AARDO is overwhelmed to partner with IIT Madras, which has been ranked top engineering institute of India for 5 consecutive years. It is also one of the premier institutions where a platform for rural technology action group has been established to create synergy between science and technology and rural development. I am very proud to announce that we are finalizing a memorandum of understanding to connect AARDO and IIT Madras network, as well as RUTAG and other institutional networks, so as to leverage and capitalize on that already developed synergy. Having perused various compendium of technologies, one can note that solutions are available for improving lives of villages, for effective rural transformation, for getting rid of drudgery of rural folks, especially women, to enable them to acquire basic facilities often prescribed by UN agencies as human rights to lead dignified lives. E-exposure visits for our member countries on some technologies in the RUTAG compendium will be organized shortly. Ladies and gentlemen, AARDO, the African Asian Rural Development Organization, is a very much rural-centric organization with the spirit of South-South and triangular cooperation. And most importantly, we've got the African Asian solidarity. We operate from New Delhi with 6 regional offices located in Asia and Africa. With an experience of nearly 6 decades, AARDO enjoys an observer status in many UN organizations, and we partner with many institutions. As such, we provide one of the best platforms for pooling of experiences, best practices, appropriate technologies, innovative ideas, and information among our member countries. Ladies and gentlemen, we are all going through the pandemic, and we know that the clarion call from COVID, which has taken humanity back, is to focus on a humane approach, to put science at work for society, especially at the village level, so that there can be village transformation. Technology transfer is thus viewed as an engine of rural growth, as indicated in the video we were watching right from the beginning. It's an engine of growth for rural development. And the level and cost of technology are also very important determinants of rural development. The AARDO Secretariat has thus provided a very prominent place for rural technology dissemination and an ecosystem aiming at raising awareness with respect to importance and application of rural technologies has been conceived to assist all our member countries in achieving and supporting them in achieving the UN SDGs, and for some of them, the African Union 2063 agenda. Ladies and gentlemen, we are all aware many initiatives are presently being carried out, but we need to speed up and scale up the transfer of innovation, disruptive as well as contemporary, affordable technology in other member countries, so that we can witness real rural transformation. We need resilience building and inclusive growth. Indeed, immense scope and potential for development and transfer of innovative, affordable technology, and their adaptability have to be fully tapped, especially with new developments, such as we know many governments are offering some rescue packages after COVID, and we have got also development from the Africa Continental Free Trade Area, which will be accelerating intra-Africa trade and make Africa a very attractive investment destination. Africa and Asia, as well as the whole world, will stand to benefit with your full commitment and involvement in identifying and transferring appropriate technologies. Post-harvest technologies, technologies enhancing small farmers' productivity, letting them access to value chain, collectivization, traceability, financial inclusion will all assume great dimensions. Moreover, we have to analyze appropriate policies, models for transfer of rural technologies that are culturally, economically, and socially suitable to the areas in which they are to be implemented as a precursor to sustainable development. Advanced information technologies are providing, ladies and gentlemen, today a great opportunity to create new partnerships and novel models to enable innovation and appropriate technology development to percolate down to grassroots level on a massive scale to support sustainable development efforts in Africa and Asia, and obviously in other parts of the world. Dear participants, your active participation will have important ramification on technology transfer to reduce poverty, inequality, unemployment, to overcome backwardness, and to solve many socio-economic problems in rural areas in your respective countries. AARDO will always be ready to partner and open up its network to inoculate our rural areas with appropriate technology. Please, ladies and gentlemen, be connected with us. Thank you to respected Professor Bhaskar Ramamurthy and the whole team, and to all of you who have been supporting directly and indirectly, and to all my participants in this international training program. In keeping with the spirit of the world is one family, the panorama of affordable, innovative technologies and solutions for rural development will save many from reinventing the world. Thank you very much.
Your Excellency, we thank your presence in today's event, and we are extremely privileged to have you as a chief guest. May I now request Professor Abhijit Deshpande, Professor, Department of Chemical Engineering, Professor in charge of Rural Technology Action Group, to do the vote of thanks and concluding remarks.
Thank you, Ujwala. First of all, I would like to thank the teams of AARDO and the Dean Global Engagement Office at IIT Madras, who have worked tirelessly over the past few weeks to envision and plan this so that we could begin this journey together. We would also like to thank the leadership roles provided by His Excellency Dr. Manoj Nardev Singh and Professor Bhaskar Ramamurthy. I thank all the participants who are going to be basically the carrying forward of whatever the deliberations that happen over the next few days. And finally, I would like to thank all the speakers and moderators of this training program who, with the planning of AARDO and Dean Global Office, have come together to be part of this initiative. So thank you all for being part of this inaugural session, and let's hope that we will have a very fruitful journey together over the next few days. Thank you.
Thank you, Professor Abhijit. We will now commence the program of today, which is innovative technology for sustainable food production, particularly post-harvest technology and value addition. Rudra, next slide, please. So day one of the 8-day schedule, we have Professor Abhijit Deshpande, who is going to moderate this session, and Professor Shankar Krishna Pillai, who is the speaker of today's theme. A brief few words about Professor Abhijit Deshpande. Professor Abhijit Deshpande is a professor at Chemical Engineering, IIT Madras. His focus is on obtaining the understanding of polymeric systems, more specifically their aggregation and gelatation behavior. Rheology is used as a probing tool to investigate polymer blends, sulfonated polymers, cross-linked hydrogels, supramolecular living polymers, and polymeric composites in his group. His teaching interests include specialized courses in fluid mechanics, rheology and continuum mechanics, and core chemical engineering courses such as mass transfer and the thermodynamics. Professor Abhijit, I request you to take over the session. Thank you, sir.
Yeah, thank you again. Shall I share my screen now?
Yes, sir.
Yes, please. Please share, sir.
Just give me a minute. Yeah, can you see the screen? Hello?
Yes. Yes.
Yes, sir.
Yes, we can see.
Yeah, is it sort of going ahead? Is it going to the next slide? Is it full screen?
Make it full screen, sir, please.
No, I have made it. So okay, I think I will need to. I think I'll just share the whole desktop possibly, and that will take care of. Now, can you see the full screen? Okay.
Yes, sir.
Okay. Yeah. So again, what I will do to set the stage for the next few days of program, I just wanted to highlight the IIT Madras rural ecosystem also, in addition to getting into the theme of today's presentation, which Professor Shankar Krishna Pillai will follow after me. So I'll just give you a quick glimpse of IIT Madras and its rural ecosystem. I know that among the participants, there are policymakers, there are government officials, there are academicians. So I just wanted to talk about this ecosystem and how do we actually now incorporate interests of AARDO and IIT Madras going forward. And I'll also spend a couple of minutes on Rural Technology Action Group at IIT Madras. So basically, if we look at the gamut of activities where the rural development issues and technology focus comes in, at IIT Madras, we have student activities which could be involved. We would have entrepreneurship and business incubators. We have also social entrepreneurship and of course, science and technology in rural development. So in terms of student activities, we have several groups, several festivals that students hold, several initiatives that are student in charge of. For example, this is a specific contest that was held by mechanical engineering department students, where the idea was to design new solutions for agricultural areas. And the reward for such an event was in fact a support for incubation. And that's why this news story talks about how IIT Madras is making students agripreneurs. The New India internship is also another way in which we have students going into the rural areas to identify and also to give solutions regarding technology problems. The other facet is related to entrepreneurship, as I've already mentioned. And so, for example, closely associated with IIT Madras, in the research park, we have Rural Technology Business Incubator, which incubates rural technology startups, not only from IIT Madras, but from a wider community. And going forward, given that many of the issues associated with social entrepreneurship and rural areas are unique, though there are commonalities, there are also very local contexts. There is always need for training in terms of capacity building, outreach, and then how to identify requirements and so on. And our Center for Social Innovation and Entrepreneurship does these activities. And finally, science and technology. We have entities like RUTAG, Center for Technology and Policy, and SIDDHI, through which this event is also being organized, where we focus on socially relevant technologies, technologies for self-reliance, and specifically looking for rural development as an overall goal. So one of the questions that, of course, comes to my mind with international engagement, what are the ways forward to put in some more linkages in place that will, and that's where I think dialogue between IIT Madras and AARDO will help resolve this question. Maybe I'll pause for a moment and see if there are any comments regarding this particular slide. Any comments or are welcome. I'll just okay, I'm just looking at some of the comments as we go on, so that maybe we will proceed. I'll just give it half a minute more in case there are any suggestions at this point regarding this. What could be specific steps where these question marks are. Okay, one of the question is what is social innovation? So this is related to basically social entrepreneurship and social innovation are phrases to indicate the location of the innovation and entrepreneurship within the domain of societal goals. And though as part of being entrepreneur and as part of being innovators, we would like solutions to reach there, and entrepreneurs would like to have earnings and profit at the end, but the focus remains on the societal goals. And so that's where the enterprises which are with these as their focus tend to have different facets, because there's far more closer linkage with the social setup, and there is far more closer linkage to the local context. And as we all know from our several countries, rural context can change within a few kilometers also. And so social innovators and entrepreneurs have to keep this changing context in mind, rather than looking at a very homogeneous sort of a customer base. And some of these issues are thought when we look at social innovation and social entrepreneurship. Right now, we being an academic institution, so I'm not aware of the BRAC or the Grameen Bank model, which is being asked about. But we being in the academic institute, our focus mainly has been on training and research. And so through this social innovation and entrepreneurship, or as well as RTBI, we actually give support in terms of what we know from a technological and management and from a social sciences perspective, what are the main considerations when one deals with rural development. So I think there is sufficient interest on CSI, and so maybe we will note this down, and Ujjwala, maybe we will see if there can be, something related to CSI in one of our future days. So maybe I'll move on now and quickly introduce the Rural Technology Action Group in the few minutes. We basically identify problem statements. So many of the problem statements that we work on have already been specified by the users or by stakeholders in the rural domain. And this is done through non-governmental organizations, governmental organizations, agencies. And we basically provide and enable seat support to faculty, internships to students, and so on, to make these technology solutions feasible. So basically, RUTAC's role is to provide a technology solution. And of course, given the focus on rural technology, we provide the immersive experience of working in very specific contexts of the rural development. Our students and faculty, through their R&D and innovation, interact with other stakeholders, which are NGOs, individuals, agencies. Many times we are also approached by individuals who face a specific problem, and then it's our job to figure out if there is a wider role for this kind of a technology, and then start working towards its solution. And there's a close interaction with users and innovators and entrepreneurs to have our solutions reach a wider audience at the end of the day. And this is just a panorama of some of the technologies. At this point, it's just to give you some of the phrases: coir spinning machine, pottery development, this is palm liquid, grass mat weaving, handloom, charkha and khadi related projects, assistive technologies for braille note taker, and affordability as well as adaptability is one of the key, a couple of key ingredients in all of what we are doing. Feasibility for sanitary napkins, charcoal production, lac washing process for tribal. This is an Andhra Pradesh Odisha project. And so there are several such projects which basically span the key sectors of livelihoods, textiles, assistive technology, health and sanitation, and energy. And of course, the list goes on. At this point, what I'll do is just give you a small example, given that the theme of the talk is related to agriculture. This is a small scale paddy thresher which we have done work on, where the labor supply demand gap leads to a major issue related to paddy threshing operations. And large scale threshers is always not feasible given the small and marginal farmers and the number of them that are involved in many of our countries. And the other option of manual threshing is actually very cumbersome, as well as availability of labor at the time of your choosing may not be always there. So we therefore have this unit which does require human intervention, but at a much more efficient level, where this thresher can be used for doing the threshing. And we have actually tested this for several Indian varieties. And so many of these Indian varieties which are now being grown in larger and larger amounts by smaller farmers, because they value their value is much higher in terms of market potential. And so we found that this machine works for 98% efficiency. And so how does this kind of a project come about? And one of the main thing is basically the innovative design that goes into it with faculty and students of IIT Madras. However, farmer input, which from the design to field trials. So from conceptualization all the way till field trials, we take the help of farmers. In fact, in this case, the interns, the students who worked on it also belong to small farm holding kept families, and that brought in additional inputs. Then field trials, of course, are done in various geographical locations. And simultaneously, we actually interact with fabricator entrepreneur so that manufacturability of the solution and its wide scale availability is sort of widely distributed. And so there will be more chance for us to talk more about many of these technologies. There are several members of the RUTAC team, as well as the faculty coordinators, who make the overall context of rural technology within IIT Madras possible. So with this, I'll stop now. And in terms of our next speaker, we have Professor Shankar Krishnapillai, who's the professor in mechanical engineering department of, there are several members of the RUTAC team, as well as the faculty coordinators, who make the overall context of rural technology within IIT Madras possible. So with this, I'll stop now. And in terms of our, hello?
Yes, Professor.
Hello, can I go ahead now?
Yes, Professor.
Sorry, yeah. We are doing okay with time, right?
Sure, sir.
Okay, yeah. So I'll welcome Professor Shankar Krishnapillai. He's a professor of chemical engineering, a professor of mechanical engineering, and he's also head of the machine design section. He has collaborated very significantly with the Rural Technology Action Group, as well as socially relevant projects and the corporate social responsibility projects at IIT Madras. Colleagues, he and his colleagues from machine design have been central in various projects where new implements, new instruments, and new mechanisms have to be thought of in order to serve the needs of rural development. In this talk, what we hope to do is to highlight the innovation that is required for making an affordable and efficient solution in the context of rural development. That implies also the use of latest tools for designing and validating and implementing And the solution, though, might seem simple at first. For it to be successful, we also have to do a lot of analysis using computational tools or whatever tools at our disposal. And so hopefully Professor Shankar's lecture will give you an idea of when we work on many of these technology solutions, what goes in, and also there are opportunities for several such products for us to work together in future. So Professor Shankar Krishna Pillai, please.
Thank you, Professor Abhijit. Am I audible?
Yes, yes.
Yes, yes, yes.
I think I'll share my screen. I have shared my screen in the full screen mode. Is it visible now?
Yes, it is visible.
Okay.
Yes.
Okay, so I am Dr. Shankar Krishna Pillai, Professor and Head of the Machine Design Section in IIT Madras. I have been asked to give a brief presentation on the panorama of innovative technologies for rural development. And as you can see, I come from this mechanical engineering department, and we are basically hardcore engineers. But I have tried as much as possible to minimize the technical content of the slides and to highlight the applications and the advantages to the end user, who are the farmers and the farm laborers. Okay, so let us start this thing. This is my brief background, but Professor Abhijit had already showed a slide about me. I'll basically repeat some highlights. I completed my PhD at University of Oxford 1996. Then I joined IIT Madras in 2003. And I became a full professor here in 2013. And the prime area of my interest is mechanical design. Okay, and also these other areas. But after joining IIT Madras, I have been exposed to various applications of mechanical engineering to rural technology. Okay, the reason is that a number of people approach us, that is farmers, entrepreneurs and all, requesting solutions to us. For example, a better way to extract oil, or a better way to make, or a better way to extract, what do you say, users, or a better way to make the fire rope. Now, I basically work here, that is the machine design section. Machine design section is a part of the mechanical.
Sorry, Shankar, just one moment. I request all the participants to mute at their end because we are getting some disturbance.
Yeah, the audience can mute there.
Yeah, please mute. Ujjwala, can you just see if you can spot somebody, and can you please mute?
Yes, we are checking already.
Yeah, please check. Yeah. Okay, Shankar, please go ahead.
Okay, so what you are seeing is the machine design section where myself and many of our faculty work. We solve this mechanical design problems. The machine design section is just one part of the mechanical engineering department. There are other sections like thermal and manufacturing sections. Thermal sections are mainly interested in the engines, boilers, and things like that. So our section has a well-equipped lab with computer-aided design facilities. So we can do all type of simulations of mechanical design in the computers. That is, before we fabricate a product, we can simulate them in the computer and see the performance. And also, we have a large number of research labs which are involved in the hardcore engineering. Okay, you can see all these labs: advanced materials, then computational mechanics, then tribology and all that. But in addition to this, we also work in the socially relevant areas, okay, like this rural technology. So we not only concentrate on this high-tech areas, we also concentrate on the problems brought by the common farmers and the common public. Okay, so now we go to the technologies to be discussed in today's presentation. So there are 5 topics here, and the first one is portable cableway for post-harvest resource collection, and second one is a monorail-based agricultural transportation systems for post-harvest resource collection. Third one is to make a household cold press oil expeller, which is useful for small farms, and how a farmer can make some extra income by generating the cold press oil in his house. And another one is the low bed tractor trailer for agricultural applications. All these things add value to the food products. And the last item, that is item number 5, is specific to coir. Okay, because we have certain consultancies with the coir industry in Kerala. Kerala is just adjoining to our state. So we have the close technical and social relationships with them. So we have developed a tabletop coir machine, which is mainly useful for women. Okay, and also now we are modifying an industrial size coir machine for improved performance and automation. Now, all these technologies have been developed using funds from the following sources. First is the corporate social responsibility funds from industries. Or in other words, as per the government rules, industries are required to give 1 or 2% of their profits to corporate social responsibility. I don't know how it is in other countries, but in India, there is a rule like that. Then second source of funds is from the rural technology cell funds, which Professor Abhijit had already discussed. Then third source of funds is another department called socially relevant technology funds. So basically the products we have developed are done using funds from these 3 sources. And I would like to express my gratitude to these sources. Okay, so now we'll go to the subject matter. The first item is portable cableway for post-harvest resource collection. Okay, so let us see what this is about. Okay, so a simple economic cableway has been developed, fabricated, and tested for transportation. That is for agricultural goods transportation. And it can transfer all these loads from farm to collection points. Okay, so in this photo, you can see the final output. I will use the pen here. Okay, so you can see this portable post here. This portable post can be carried in a truck and erected in the field. And here you can see a trolley. Okay, the trolley has 2 wheels here, and it moves on the steel cable. Okay, and then this trolley is pulled back and forth by means of this rope. Okay, this yellow rope. The movement of the yellow rope moves the trolley back and forth. And here you can see a simple sling. And in the sling, you can put your agricultural produce. And this entire thing can be taken in a truck and erected in the field. So now we look at a few slides on how this was developed and what are the challenges and what is the background and all those things. Okay, so background of the problem. As you know, India is one of the largest sugar producers in the world, and it is mainly produced from sugarcane. Actually, Brazil is the largest sugar producer in the world. India comes second or something like that. And sugar is made from various crops: sugarcane, sugar beet, and palm jaggery. And sugarcane is the main source, at least in India and Brazil and all that. Sugarcane is the main source. And the immediate reason for this project is the problems faced by sugarcane farmers in this Tamil Nadu district. And these problems are typical of other farmers also. So let us see what are these problems. Okay, there is a significant shortage of labor in the Indian farming sector. So all sorts of agricultural activities are affected. Not only post-harvest, but harvesting and seeding the field, intercultivation, all these things are affected. One of the reasons for significant shortage of the labor is that the youngsters like to go to urban areas where the pay is better. And also many youngsters don't like the drudgery of the field. Okay. And another important factor here is that due to the small size of the Indian farm, that is, there used to be a land ceiling act until about 10 years ago, according to which every farmer can hold only about 10 or 15 acres of land. Okay, the remaining will be taken over by the government and given to people who have no land. So because of this land ceiling act, the Western type of large-scale mechanization is not possible. Okay, that is one reason. Then another reason is that wetland fields, that is agricultural fields, which are surrounded by ditches and canals, make vehicle entry difficult to some farms. So wetland fields are fields which are near some rivers or lakes, where the water can enter the fields through a small canal. Okay, and the field is under a few inches of water. So a lot of cultivation takes place in the wetland fields, and you cannot make any roads or any type of pathways into the field to bring back the agricultural produce. Okay, then another highly important reason is that is they want to avoid the manual handling of agricultural produce. Some time ago, I met a representative from a European trade organization. She is coming from Brussels. She told me that a lot of bananas exported from India are wasted because of the bruising of the bananas when they become ripe. And this bruising is because they are carried on the head, or they are carelessly thrown around and things like that. So this cableway is a device where you can transport them across long distances without bruising or injuries. Okay. Some photographs are here about the post-harvest situation in the field. You can see that the workers are standing in the sun, and one head load of sugarcane is 25 to 30 kilograms. You can see this. Okay. So the workers, I mean, if there's no cableway, all these workers have to put the sugarcane loads on their head, and they have to walk hundreds of meters back and forth. And also they suffer the spinal injuries after a long period of work. And here you can see the wetland fields. You can see the fields which are crisscrossed by small canals and with the palm tree trunks as the bridges. Okay, so the workers have to walk across these bridges, okay, carrying the loads on their head. So these are some of the difficulties. So according to this journal paper, according to this journal paper, cableway has certain advantages. It is the most economical means of material handling. That is minimum energy consumption and labor requirement. Why does it have minimum labor requirement? Because you need only two persons to operate, like one person at each end of the cableway, and maybe one person somewhere in the middle in case something gets stuck. And it moves material in a straight line. That is from the origin to the source. The cableway moves in a straight line. It can cover rough terrain because it does not touch the ground. Whereas if we want to make a road or something, you have to level the rough terrain. It has minimum ecological impact because it does not disturb the land in between the cableway post. Okay, because the loads are going above the ground. Okay, so you can see that this cableways are extensively used already in industries, but these are all high-tech cableways. We are not planning to use these type of expensive cableways. Okay, so you can see here that all these trees and vegetations are undisturbed by the cableway because the loads are hanging on the top, and you need not cut these trees. Okay, so various type of cableways are there, and we are going to use the hauled by rope method, and also we are going to use by cableway. That is the two cableways, one for onward and one for return. Okay, so objectives of this cableway is that it should be simple and economical, and you have to use the readily available parts, easily erectable in the field, and after use it can be removed and shifted in another field. Continuously transport loads of 25 to 30 kg over a distance of several hundred meters, and it can prevent damage and bruising of agricultural products, especially delicate fruits like banana. It will reduce the labor cost and it gives value addition due to the above causes, avoids the spinal injury to workers in the long term. Okay, so you can see a schematic diagram of this cableway. Actually, I have simplified it a lot. Okay, so these are all portable posts. So these are all posts which can be carried in the field and erected on site. So these posts are openable in the field. You carry them in the collapsed way and you open them in the field. You can see top cable, you can see a bottom cable. Okay, so then you have a cable tightening device. Cable tightening device is required because otherwise the cable will sag under the load. So once the cable sags, then the load will be stuck. So you have a loaded trolley, okay, moving in a particular direction. And you have the empty trolley, okay, which moves in the opposite direction after it has delivered the goods. So two trolleys are there, that is loaded trolley and empty trolley, and they move on different cableways. And how do these trolleys move? Okay, the trolleys move because they are attached to this rope. You can see a red rope called recirculating rope. Okay, this recirculating rope is connected to a winch here. And when the winch rotates, the recirculating ropes moves in the clockwise or anti-clockwise direction. So the loaded trolley moves in this direction, empty trolley moves in this direction. Okay, so this is the picture of a portable post. Okay, so it is made up of two trapezium type of posts which are clamped at the top. Okay, two trapezium type of posts which are clamped or hinged at the top, and they are kept apart by these tie rods. If the tie rods is not there, they may come together. And this portable post carries a top cableway and a bottom cableway. So this post can be carried in a truck and it can be opened up in the field and erected there. And how are these trapezium-like posts made? Okay, the trapezium-like posts are made from a tubular form. Okay. tubular frame. Okay, so this can be easily made in any workshop. What you can do is that you can take a length of tube and you can bend it in the form of this trapezium. Okay, so it is very easy to do in the local workshop. Okay, then another important thing is that suppose you put one sugarcane load here, okay, of 50 kg, then various type of forces will act on the post. So each post will suffer a compressive force of 300 kilogram force. Okay, so the post should be made strong to withstand this force. Not only that, the cable will be having a tension of 420 kilogram force. Okay, so you can see that if you add 4 or 5 concentrated loads of sugarcane or the banana, it will cause a cable tension of 2 tons. So because of that, we use a cable which can withstand 8 tons. So 8 tons means 4 times safety factor is there. Okay, so you can put 20 loads. Okay, so 12 mm diameter cable can carry some 20 trolleys as per this analysis. And also each post must have to be sturdy to withstand this compressive loads. So you can see a post being erected for our prototype. Okay, it is about 2.3 meter tall, 1.8 meter wide when you open it, and it is made of a simple frame. Okay, it is a frame made of a tube which is bent in the form of a trapezium. Okay, so in this picture you can see the top cable, and you can see the holder for the bottom cable. The bottom cable will carry the returning empty trolleys. Top cable will carry the loaded trolleys. Okay, then next is how is the trolleys made? So in all these designs, we have economy in mind. So you can look at this trolley here. It is made of a simple triangular frame, and it has 2 nylon wheels. You can see the 2 nylon wheels which are easy to make. And one of the advantage of the nylon is that it has very less friction. So this nylon wheels move on this cable. You can see here. And you can see this yellow rope here. And when this yellow rope is pulled, then the entire trolley will move left or right. And we use a simple sling here, okay, to load the products. And if you use a simple sling, you can load whatever you want. Sugarcane, banana, tapioca. You can put it in a bag and put it in the sling. Okay. And you need to have a winch and a motor to pull this rope, that is to pull this yellow rope. So this recirculating rope is pulled by a winch powered by a 2 HP motor. You need a winch drum, okay, 0.3 meter or 1 feet diameter. Okay, so this is the winch drum, and the rope is wrapped around the drum. Okay, so when the drum rotates, the rope is pulled around. We used an 8 millimeter diameter nylon rope. Okay, so that is about the winch. So a lot of technical details have been removed, and only the bare minimum description is shown here. So this is for those who want to replicate this device. And then how is the cable tightened? I told you that when you put the trolleys on the cable will sag. So to prevent the cable from sagging, it has to be tightened. So the cable is tightened with a 2-ton chain pulley block. So this is what is called chain pulley block. You can buy it at any workshop. So in the big passenger cableways and all, cable is tightened using hydraulic device. But here we use a ordinary chain pulley block, which is available at any workshop. So what you do is that this one end of this chain pulley block is buried in the soil. Okay, so it is buried in the soil. That is, you attach a concrete block to it, and bury it in the soil, and this other end is attached to the cable. Okay, And you can tighten the cable by pulling the side chain. That is, you pull this chain downwards and you can tighten the cable. So the cable is taut. Okay, this cableway was tested over distances of 25 meter, 75 meter, and 100 meter. So our budget was only for up to making 100 meter, and it worked successfully up to that distance. Okay, so sugarcane loads up to 5 trolleys at a time were hauled continuously at a speed of about 1 feet per second without the brake. You can increase the speed by changing the gearbox. So every 16 seconds, a load can be attached. Okay, so let us look at some photos and videos. So this is the photo of a sugarcane load being transported in this cableway. And this picture shows all the cables arranged in a row. Okay, so it stretches for about 100 meters on either direction. So this picture nicely shows the perspective view of all these cables, of all these posts. Okay, so this is another side view. And here you can see the rope which holds the load. Okay, this is the top rope. This is the bottom rope. There's a small video here which I'll try to show. Let us see if this video works. Okay, it's working. So this is one of the field trials. Okay. So the cableway has just been started and it's starting to pull the loads on top.
Shankar, maybe we can have a small break for some questions, either from your side or from their side.
No, one more transportation device is there. After that, we can.
Okay, sure.
Monorail. Okay. So shall I stop the video or show sufficient? You can see the loaded trolleys on the top. Okay, so let us continue. The cost of cableway with the electricity generator is around $3,500. So it might need 4 people half a day to install this cableway. The longer cableway does not require proportionately more effort because we keep on adding more posts to the existing number of posts. So once a cableway is installed, it may need 3 to 4 people to run it. Okay, so the longer the cableway, the more economical it is. So manual labor can be saved depending on the distance covered. Okay, so this is the illustration of the portable cableway. So the next slides I'm going to show much more improved transportation device. So it is called monorail based agricultural transportation device. So we got this idea from the monorail conveyors used in factories. Okay. In this picture, you can see the monorail conveyors used in the factories, and we adapted the same for the field. Okay, but the main changes are that the economy and ease of installation in the field. So we have adapted the concept of cheap agricultural transportation used to cover large distances in the field. Actually, the factory monorail conveyors are for somewhat short distances, but our monorail has to stretch for 1 kilometer or more. So we'll briefly go through this. The advantage of the monorail, they are in many ways similar to that of the cableway. It is an economical means of material handling, okay, because there is less energy consumption and labor requirement. So just like the cableway, you need only 2 people at each end of the monorail. Then it can cover the rough terrain by skipping the rough sand in between, and the load does not touch the ground. And because of all this, it has the low ecological impact. So it's better than the cableway in some respects. So it can carry the heavier loads, because the monorails is actually a type of overhead railway. Okay, it is actually a steel beam, and unlike the cableway, you can have the curved path for the monorail. Only thing is that the overhead rail has to be curved. Then it is easy to extend by adding more rails. Okay, whereas unlike the cableway, as the length of the cable increases, then the sagging will increase, and you have to use more force to tighten the cable to avoid the sag. That problem is not there in the monorail, and only one operator is used in the either end. Okay, so this is just a schematic diagram of this monorail system. You have this rail here, and here you have this traction unit. Traction unit is something like a railway engine. Okay, so it has an engine here, and it will move over the rails. So this is an engine. It will move over the rails using these wheels. Okay, and you can see the trolleys here. Okay, this is trolley number 1, trolley number 2, trolley number 3, and so on and so forth. So just like a train engine pulling the coaches behind it, the traction unit will pull all the trolleys behind it. Okay, and you can see all the loads here. Each of these loads can be up to, say, 40 kg. Okay, so all these items are commonly available in the local workshop, and it's easy to make, and no expertise is needed. And you can look at the design of the rail. So one span of the rail is 6 meters. So it covers a large distance. Okay. If you look at the rail, it has a box section. Okay. Look here, it has a rectangular section or box section. So why is a box section chosen for this? Okay, the main reason is that the wheel of the trolley has to roll over this section. Okay, that is why box section is used. Another advantage is that this type of box section is used in the bus body building workshop. So it is readily available, and it is available in 6 meter lengths. So in one shot, you are covering 6 meters. And it is seen that only 10 millimeter or 1 centimeter sag is noticed when 5 trolleys are loaded in one span. So the rails are very rigid. And how to design the trolleys? You can see the picture of a trolley here. Okay, the trolley is about 1 meter long, and it has 2 wheels here. 2 wheels are made of cast iron, and these 2 wheels you can also see in this picture. Okay, so the wheels of the trolley move on this rail. Okay, left to right. Okay, so just like a railway coach. So, but to minimize the expenses and to make it simple, only 2 wheels are used. And you can see a sling here. Okay, this is a sling. You can see a sling here, and the loads are added to this sling. And in this prototype model, we put the dummy iron loads of about 40 kg. Okay, so this is the basic design of the trolley. It is very simple, easy to make. It has only 2 wheels, and it moves smoothly over the box type of rails. Okay, then next most important is the traction unit or the engine unit, which will pull all the trolleys. Okay, so you can see here one of our preliminary designs, which is an initial model. which is made from a scooter engine. Scooter engine has about 9 horsepower or something. And in this initial model, there is no self-starting and there is only forward gear. We just wanted to see if it will work. And in our final model, we added the self-starter. Okay, so it's easy to start this trolley by turning a switch. Okay, so you can see this electricals here. And forward reverse is there. You need the forward reverse because once this trolley reaches the end of the rail, it has to come back. So you need forward reverse. Then we have a gearbox to speed the engine RPM to the trolley wheel RPM. That is about 50 RPM. So using this trolley unit, speeds of about 0.6 meter per second or 2 feet per second are used. So this type of speeds are enough because if it goes too fast, you cannot unload the agricultural produce from the trolley. So the speed of the trolley should be maximum twice the walking speed. Only then the people can catch up with it. And post, okay. These are the posts of the monorail cableway. Okay, the posts are made up of steel sections of 100 into 100 into 2.5 mm. And you can see that in this particular picture, the post has a steel shoe. Okay, so it is this type of post is portable. Okay, you can take this entire post in the back of a truck and you can put it in the field. Okay, there's no need to dig it and all that. Because of the steel shoes, it will be stable. Now another alternative, if there is no provision for steel shoes, is that you can dig a hole in the ground, you can fill it with concrete, and you can attach this post and you can bolt it to the concrete. So in this case, it becomes more like a permanent post. So various options are there, temporary and permanent. Okay, and how are the rails joined? You can see a rail here. Okay, 2 rails are here, and they are joined by insert. Insert is a smaller rail which fits inside the bigger rail. Because of this insert, the successive rails can be easily fitted together. Okay, so you can see the insert here. Okay, insert here, and the 2 adjacent rails are fitted together with this insert. And with this method, it is easy to keep on adding successive rails and to extend the distance of the rails. Okay, so this is just a prototype testing with the traction unit and 5 trolleys. And these are all dummy loads. Each load may be about, say, 40 or 45 kg. Okay. And these are the rails. Okay, these are the box section rails. Okay, so now we can see the actual implementation in the field. So this monorail system was implemented in a nearby field up to a distance of about 200 or 250 meters. And we had budget only for that much of distance. Okay, so that is the why we stopped it at 200 or 250 meters. But in theory, we can keep on adding more rails and go up to several kilometers. Okay, then this is another picture where 2 operators are needed. So the speed of the trolleys can be adjusted with gear and accelerator combination. The best speed is little more than walking speed for easy loading and unloading of the trolleys. Okay, if it is too fast, it is difficult to take things out of the trolley. Okay. This is another view which shows the traction unit and all the components. I think a small video is there. Let us see if it works. Actually, this was done during the Corona time, so we could not add the actual sugarcane load or banana load. There were not much workers available, so we had to put the dummy loads.
Shankar,
Ah.
we are nearing 3:30 now.
Okay. So yeah. So any questions you can ask, or you want to go to oil expeller, or?
Yeah, maybe we'll just take a pause and see if there are questions. And then there is already one question which was by Siom. Is the cable transportation effective?
Effective means in what sense? In economically or technically, technologically? Technologically, it is working very well. And the main advantage of this is that you need only two people at either end. You don't need the other laborers, especially as the distance between the source and the destination increases. The labor you require increases very much. But in case of cableway, it is insensitive to the distance between the between the source and the.
Okay, there is one more comment though, and maybe in some other discussion we'll come to know from Michael Samwele, who said that he's appreciative of the idea. Michael is also saying that already thinking of a different application based on your presentation.
Different application.
Yeah, so we'll have to see.
Yeah, it can be used for not only agricultural products.
Yeah, exactly. Yeah. So maybe okay, we can go ahead to the expeller, and if the questions come, okay.
Yeah, but I cannot see the comments when I am giving the.
Yeah. That's why I'm going through them. If there are more, I'll come back. But I think we can go ahead with the expeller. Participants, please include your questions in the chat box, and I'm noting them as and when we come towards the end. We will try to answer all the questions. Okay, go ahead, Shankar.
Okay, so the next technology we developed is a cold press oil expeller, which is useful for farmers and especially the women workers. Okay, so this was developed on the feedback obtained from many sources. Okay, Indian rural farmers can have this compact oil expeller in their farm to extract good quality oil, which is an additional income for them. So many of these farmers will be cultivating groundnuts or sesame seeds or things like that, other type of edible seeds or dried coconut. They can extract the cold press oil, which fetches a premium price. So their wives can do this at home and generate a good income. So oil cake, the waste material, is a nutritious animal feed. And a wide range of domestic seeds need to be crushed. So when we make oil, cold press oil expeller, it must work for a wide range of seeds, not just one seeds. That is one of the challenge. Then the current oil expellers in the market are either very expensive, large scale, or not satisfactory in performance. And the small tabletop models which are advertised in Amazon and all, which we purchased one or two and tried, they don't actually work well. And they're also not cold press oils, although they claim to be, because inside those machines, you can see the heating coil. So the current oil expellers in the market are either very expensive and not satisfactory in performance. Okay. Then there is an increasing demand for cold press oils in the Indian global market for edible oils and cosmetics. So because of all these things, it is attractive to develop this cold press oil technology. Okay, so I'll quickly go through the differences between hot press and cold press. Some of you may know this already, but for the others, I'll quickly go through this. The hot pressing means oil is compressed with a screw or any device, but there will be a heating coil which heats the material up to 100 or 200 degrees centigrade. The advantage is that the cell walls will rupture and the oil is easily extracted. So if you use the hot press method, you can get 40 to 45% of the seed weight as oil. But the high temperatures change the chemical structure of the oil. A lot of important nutrients like vitamin E, steroids, carotenoids are lost. And also another important thing is that chemicals are added to the hot pressed oil later to regain the color, smell, taste of the original oil. So these are some of the advantages and disadvantages of hot press oil. That is, it's easy to make in large volumes, but health-wise it is not that good. So if you go to the cold press oil, oil is compressed at room temperature. So the condition is that it should emerge at below 50 degrees centigrade. But more compression effort is required because there is no heating, because the cell walls don't rupture, you get only less oil. So lesser productivity. That is, only 30% of weight of the oil seed is obtained as cold press oil. But cold press oil retains most of its natural, physiological, and chemical properties, and it retains its original taste. Okay, so nowadays in the supermarkets and all, you can see a separate shelf for cold press oils, which command a premium price. And these cold press oils, to the best of my knowledge, are made in small quantities. So the farmers have a good livelihood from this. And we took this project also based on feedback from some farmer societies. So type of cold press devices used in India. So in old times, cattle-driven oil mill is there. So you have a cow or a buffalo which goes round and round. Okay, so what you see here is a mortar and pestle. Okay, the mortar is typically made of wood. Pestle may be made of stone or hardwood. It can produce about 10 or 15 kilogram per hour. It can process about 10 or 15 kilogram per hour of seed. And nowadays, this has been motorized. It's called motorized gani or motorized oil mill. And it needs a 5 to 10 HP motor. Very high productivity is got. But we noticed a peculiar problem with this. Okay, because everything is made of steel. Due to the friction between the steel surfaces, the oil which comes out is more than 50 degrees centigrade. Okay, actually there's no heating coil or anything inside, but due to the friction between the steel surfaces, the oil temperature is almost like a hot pressed oil. It comes to around 80 degrees and so on. In fact, you cannot touch with your hand the oil which comes from this motorized oil mill. Although it's technically cold pressed, the temperature is high due to friction. So then another method is solvent-based extraction, and it is widely used for coconut. That is, the coconut milk is subjected to heating, and then it is subjected to centrifuging. And when you do the centrifuging, the oil will come at one level, and the other lighter components will come on top, and it can be separated. But for other seeds, centrifuging will not work. You need to use artificial solvents like hexane. So hexane is a chemical which can dissolve many of this natural oil and which has a low boiling point, and it is popularly used to extract the oils, but it leaves a residue of chemicals. Okay, so definitely cold press oil based on some screw or natural process is better than this. So because of all these things, we decided to take up this project. Okay, so what is the popular method of extracting oil nowadays? Nowadays, the method is to use a screw type of press. Okay, only a screw can generate the high pressures, which can squeeze oil out of the seed. So typically, the screw has a reducing depth to compress and crush the seeds. Okay, so you can see here. So this is an oil seed, and it is moving from left to right. you can see that the depth of the screw is decreasing and the oil screw will be slowly crushed here and the oil will be extracted. Okay, this is the principle of the oil screw. And we also propose to use the oil screw. Okay, so this is the basic principle of a oil screw cold press extractor, but it does not work very well. Okay, we needed to do further improvements to this. So you can see a cylindrical type of oil screw here, and you can see that the depth of the screw gradually decreases, okay, from left to right. So the oil seed is gradually pressed and squeezed as it goes from left to right. Okay, and as the oil screw is gradually squeezed, the oil will drip out through the holes in the bottom like this. Oil will drip out of the holes in the bottom. If you have a tray here, this oil will be collected. And the oil cake, that is the waste material, will come out of this narrow hole here. Okay, you can see a narrow hole here. So the oil cake will be extruded through the narrow hole at the end of the screw. So basically you put all your oil seeds in this hopper, and as the screw turns, okay, so now that is the things. Okay, so what we found is that the cylindrical type of oil screw expeller does not work well to produce the cold press oil. You need to have some more force. Okay, so we have developed a tapered screw like this. Okay, especially designed tapered screw has been designed to exert more compressive force to extract the cold press oil. Okay, so this is a novel concept which gives higher compressions due to dual effect. So this type of screw can produce cold press oil in the tabletop models. Okay, so what is this dual effect? Okay, the dual effect is that the diameter is reducing here. Okay, so initially the oil seeds occupy a large diameter here, and at the end they are squeezed into a smaller diameter. So that is one effect. And then secondly, the depth of the screw also decreases. Let me use this pen. Okay, the depth of the screw also decreases as you go. So depth of the screw gives another compression. The depth of the screw decreases. Okay, so double effect is there. Reducing diameter as well as reducing depth. And we found after a lot of trials that this works very well. Okay, so we made a screw like this. It's actually a conical type of screw, tapering type of screw. So this is the screw. This is the shell. Okay, this is where the seeds are put. The seeds are put here. Seeds are put here. Okay, so this type of screw we found to give good compression. Okay, this is the model which we made in our workshop. You can see here. Okay, so it uses a half horsepower electric motor. Okay, you need half horsepower because you need a lot of energy to squeeze the green seeds. Okay, without heating the seeds, if you want to get cold press oil, you need a lot of energy. So that is how half horsepower electric motor is required. And the screw has to rotate at a very small speed. Only then you get the torque. So the screw rotates at 33 RPM. So as many engineers know, the motor will rotate at 1500 RPM or revolutions per minute. Using this gearing, you have to reduce the screw RPM to 33. Okay. Only then you can generate a high turning movement. Only then you can squeeze the seeds very well. So total cost is 27,000 rupees. including including the motor and shell and everything. And we did some tests with this machine. Okay, so first you have to remember that this is a tabletop machine, and we don't envisage a very big productivity from this. Okay, so we tried with the sesame seed. You can put 6 kilograms of seed per hour. You will get 1.73 kilogram of oil per hour. So percentage of oil you get is 28.8, and oil temperature is 36 degrees centigrade. It is as cool as the room temperature. When we put the groundnut seed, because the size of the groundnut seed is bigger, we can put only 3 kilograms of groundnut seed per hour. Maybe if you increase hopper size, it may increase. So you can get 0.9 kilogram of cold press oil per hour. So it means 30% by weight of the seeds can be got. And on the right side, you can see the oil cake which comes out of the other end after it has been dried. Okay. After it has been dried. Okay. Then finally we tried with the copra or dried coconut. This dried coconut has to be cut into small pieces. Depending on that only your input can be decided. So we cut it into sufficiently small pieces so that seed input is about 5 kilograms per hour, and oil weight is about 1.9 kilogram per hour, and copra has larger oil content than the sesame seed. Perhaps that is why we got a large output of the cold press oil. So percentage of oil you get for copra is 38%, and oil temperature is 36 degrees centigrade. So you can see that the oil temperature wise, the machine is working very well, and also the quality and taste are also very good. And the cold press oil will contain a lot of debris that has to be filtered out from the tray. Okay. And we made an improved cold press oil expeller because there was a feedback that we need to improve the productivity, that 3 kg per hour is not sufficient. So we used a 1 horsepower motor and larger screw. So when we used it, okay, we increased the input opening and also the hopper size. So now the productivity was increased by 50%, 50 or 60%. Oil of the same quality was obtained. And this current machine is undergoing trials for extended use. And because of the COVID and all that, some interruptions were there. So this is the final model of the cold press oil expeller. We have a small video of its working. Okay. So let us see if this video works. Okay. So you can see the oil cake coming on the right hand side. You can see the cold press oil being collected in a tub. So that oil has to be filtered. So this machine can be made more compact in the final stages.
Shankar, as the video is playing, there was a question related to whether olive oil can be extracted using this.
That can also be done, but I think the screw compression has to be slightly changed. I think I am not aware if olive gives more oil or less oil than this peanut. Okay, depending on that, now if you look at literature, we can design a screw for more compression or less compression.
Yeah.
Yeah.
There were other questions related to capacity and temperature and all, which anyway you have answered, and Srinivas also has been answering on the chat box.
Yeah. So that has been answered in detail here. So all
yeah.
So this we have improved also.
Yeah.
So then this is this tractor trailer. You want to skip this tractor trailer and go to fire?
Yeah.
Go to fire. Huh?
Yeah.
Okay. Okay, so technologies for the coir industry, which is mainly for women. Women workers dominate here. So first is that we made the tabletop machine for the woman coir workers. And also after that, we worked on the industrial scale machine. So this coir technology is more interesting because it is more involved with the social fabric of the people, and especially it is important to the women workers. Okay, so what is the motivation to work on the tabletop machine? So this manufacture of coir fiber yarn is an important traditional occupation in Kerala. Coir industry is of great importance to Kerala, where it is second only to agriculture as a source of employment. And another thing is that apart from using the coconut for edible uses, the coconut fiber is a waste product. So the coconut fiber from the husk is either discarded as a waste or used as a fuel. But only in few countries like India and Sri Lanka, it is processed into rope, mat, and other type of things. So it's a significant value addition. Okay. Then coir industry is concentrated in India, mainly in the Alapi district, and it provides employment to 400,000 persons. Out of it, 33,000 are predominantly women. Okay, so a lot of people who run these small scale industries, they employ women more than men. So, and the sector exports coir products of around 100,000 tons. Now, the importance of this project is that high quality coir rope is the most important product, and it is used for carpets, mats, and it is used for export. Because of the importance of this as an export product, there is a need to upgrade the technology and productivity from the traditional ways. So various reasons are to avoid drudgery, hand injury, and scarring, because the women workers will get some scarring and hand injury by feeding the rope continuously over many years. Then we need the uniform quality of rope. That's rope which is made manually does not have the uniform quality. Okay, the quality will fluctuate based on worker to worker, and also it based on various other factors. Okay, then we need much larger outputs for export markets. Okay, so because of all these things, we decided to do the tabletop coir machine, okay, which women can use. Now, another important reason is that all the coir ropes have to follow industrial standards. Okay, and you have to follow the standard, like so many twists per meter, so and so many meters per kilogram, and all that for various type of ropes. You cannot make any type of rope you like in the past and try to sell it. People will not buy it. Various different type of ropes are there. Each rope has to follow a standard with specified density, specified twist, and all that. And the machine is best to do this type of work. Okay, so in many parts of Kerala, I think I'll collapse the screen because I cannot see the top of the screen because of the Zoom menu. Okay, so now you can see the top. In many parts of Kerala, the rope is made in a traditional way, using a manually turned wheel. And recently, motorized wheels have also been used. Motorized wheels will use a motor instead of a person to turn the wheel. That is all. Okay, so you can see this picture here. One woman turns the wheel by hand to create the twist of the rope, and two women will hold a bundle of coir yarn in their lap, and they will feed this coir yarn to this machine here, and then they will walk backwards. As they walk backwards, the length of the rope will increase. So you will get two strands. So After they walk backwards about 10 to 12 meters, they will stop. So then they will get two strands, and then these two strands have to be twisted together to get the rope. So that is the traditional method. So one lady sits here to rotate the wheel. And as a small improvement, instead of this lady, they have put a motor. Okay, so that is the only type of improvement which has been done up to now. But that does not prevent these two ladies from walking back and forth long distances. So women have to walk back 10 to 12 meters, feeding the rope. Okay, so some of the details are given here. Most popular rope produced here is called Wycombe rope. So its standard specification is that per meter it should have 50 twists. And this density is that 1 kilogram of that rope will have 235 meters length. It is made up of two strands. That is, two particular strands have to be twisted together. Okay. So the disadvantages of the existing method is walking to and fro several kilometers each day. And after many years of work, bleeding aberrations in the palm and fingers, which result in scars in the hand. Okay, then uneven twist. Especially all workers don't have the same skill. So the rope produced by some workers will have lower quality than the other workers, and the twist and all will not be even. Okay, and because it violates the standards, it will not go for export. Okay, then another important disadvantage is that only 10 or 12 meters of rope is made at a time, and in the end, the separate lady has to splice up all the separate 10 to 12 meters of rope. Okay, so they can have a 100-meter bundle. Okay, so when you splice together various type of ropes, then at the place where it is spliced, the rope will be weak. Okay, and also the different 10 to 12 meter lengths will have different qualities. And when you splice them together, you get an uneven type of rope. So when this export industry came, they started demanding a uniform quality. Okay, so the purpose of this tabletop machine is that the machine makes excellent Wycombe rope, and it can make any other type of rope also if you change the gears inside. So Wycombe rope, as we saw, it follows the specification, 50 twists per meter, and diameter of rope should be 4.5 mm. And if you use this machine, you can make 6.5 meters per minute with a half horsepower motor. And the productivity is double or sometimes triple that of manual method. So it is double that of a highly expert manual worker, or triple that of an average manual worker. Okay. And another important thing is that the machine can work continuously, and the woman can comfortably sit on a chair and feed the rope. And another important thing is that unlike the other machine-made ropes, this machine-made rope does not require a nylon core. Okay, so many ropes which are made nowadays in machines, they need to have a nylon core as a stiffener. And if you put the nylon core, the rope will not be accepted for export. Okay, so they need to have the purely coir rope. So this particular machine will make a purely coir rope without any nylon core. Okay, then it is envisaged to be home use, and it is already in service in Alleppey. Okay, the popular type of ropes in Kerala. So historically, all these ropes are made in Kerala. Each has a separate use. And the most famous is this Wycombe rope, which is used for mats and carpets. This Wycombe rope is very soft. Okay, that is why it is used in mats and carpets. And another famous type of rope is this Anjutanga. Anjutanga means 5 palm trees. Okay, so this particular type of rope has much more strength than this Wycombe rope, and it is used for binding the native canoes in old times. So in old times, when they make the native canoes, they don't use nails. They will drill holes in the planks and they will tie them with rope. Okay, and this Anjutangu rope was used for that. Nowadays, it is used for other binding purposes also. Okay, so these are various type of ropes in Kerala, and you can obtain them by changing the speed of the motor or the speed of the pulley and so on and so forth. Okay, so we did a preliminary study on how to make this machine. So this is just a schematic diagram. I will quickly run through it. Okay, so the worker will have to feed the two yarns. Okay, there is an input.
Yeah, Shankar. Sorry, yeah, maybe we will have to speed up a bit. It's getting close to 4 o'clock.
Yeah, it's
over
almost. Okay. Okay, so it will come through this pistos, okay, and it is passed through the static rollers, and finally it is wound around this rope drum here. Okay. Okay, so we did a lot of tests to find the correct RPM to get the Wycombe rope. Okay, so we changed the speed of this drum. Okay, we changed the speed of this input rollers, and we changed the angle between the ropes. Okay, and we changed the distance between the input roller and static roller. So a lot of tests were done. Okay, and finally we made a CAD model with all the motor parts. You can see a lot of pulleys and belts here. The purpose of this pulleys and belts is that by changing the belts and pulleys, different productivity can be obtained. Okay, so the maximum productivity we can obtain from here is about 6.5 meter per minute. Okay, this is being obstructed by the zoom menu on top. 6.5 meter per minute. Okay, so this is the prototype machine. You can see a worker feeding the yarn. Okay, this is called yarn. Yarn. Okay, so two strands are there. First strand, second strand. First strand, second strand, and they are combined to form the two-strand row. Okay, so various trials were held. So if you have inexpert workers from outside Kerala, you need to have two separate workers. Each worker will feed a separate input roller, and they have to synchronize between yourselves. Synchronize between themselves. Otherwise, one of the yarns will stop and the other will continue to be taken and it will get stuck. Okay. Later, we bought expert women workers from Kerala. These expert women workers were very comfortable with this machine. So one woman can feed both the strands. And very quickly, they became familiar with this machine and they were able to attain speeds of 6.5 meter per minute. Okay, some video is there. You can see the. Okay, let me change to this arrow. I think we can stop here with this video. Okay, then later a final model was made with the protective covering and all that, and it was delivered to women workers in Alleppey, and they are using this machine for a long time. Some mats were made with this machine. So this mat was made with our machine. This mat was made with the traditional rat. You can forgive the English language here. It is traditional, okay? And this mat was made with our machine. So the quality of the mat made with our machine was slightly better than the manual method. Okay, so if you want, we can stop it here because next is the automatic coir machine.
Yeah, maybe we can see if there are further questions. I think most of the questions you have already answered. And there is some information like Jatropha's. I mean, there are additional seeds for which there is interest in terms of bottle good, seed oil, or also palm oil.
Yeah,
And,
all those
so,
we can.
Yeah, it's possible to look at those.
Yeah, we have to investigate how much pressure is required for those seeds. Accordingly, have to modify the things.
Yeah, Ujjwala, I just wanted to see if we can have this program going on for a few more minutes because we had inauguration today.
Sure, sir. Sure.
Yeah, so if participants have any questions, because we wanted to end this also with some discussion related to dissemination, because as Professor Shankar has pointed out, all the models which are developed, they are lab tested, then they are field tested, and many times deployed also. But deployment of 1 or 2 or 3 or 10 may not be as sort of satisfactory from a success point of view, where you would want many of these to permeate to a larger market. And so working with rural technology and technological solution, there are challenges associated with dissemination. So, so Shankar, shall we go ahead with that now?
Okay, yeah, okay.
Yeah, and Professor Shankar will remain with us, and now I request Srinivas Chigulapalli, who is a project officer with Rural Technology Action Group, to say a few words on the challenges that technology developers and people like us who are interested in implementing these solutions at a larger scale. What kind of challenges do they face? So Srinivas, please.
So can I stop sharing, or it's not?
Yeah, possibly. Yeah, I think that's fine. Maybe if we need it at the end for question answer, maybe we can again begin the presentation. So Srinivas, go ahead.
Yeah. Can you hear me?
Yes, the voice is a little low, but
yes, we hear you.
Now it's better.
Yeah. Okay. Go ahead.
Yeah. Thank you for this opportunity. I'll just put up a slide.
No, Srinivas, the voice is actually low. You can maybe.
Hello. Can you hear me now?
Yeah. Just speak a little louder, maybe.
Okay. Yeah.
That's better.
Okay.
That's better.
Yeah. I'll share my screen. Are you able to see my screen? Hello.
Yes. Yeah.
Full screen mode.
Yes. Full screen also.
Okay,
yes. Please go ahead.
Thank you. Thanks everyone. And I just want to.
No, just keep it again. Again, the voice has gone down. So just maybe whatever you were doing earlier was good.
Is it okay now?
Yes. Yeah.
Okay. Yeah. I just want to touch upon a few aspects related to how technology is bringing about development. Basically, the technologies showcased today by Professor Abhijit and Professor Shankar actually touched upon various aspects of rural livelihoods and rural ecosystem, especially working on agricultural implements and farm mechanization and some sorts of non-farm livelihoods related to coir sector. So, I mean, whatever we are talking about is basically the technology which aids for development. And when we say about development, the quality of this development is unknown. And most of the times we talk about growth, which is quantitative, and the development is more of a qualitative nature. So growth represents some quantitative change, whereas the development tells about the quality of that change. So that is more important when you talk about rural development. And when we talk about technology for development, actually it should bring out a lot of positive societal changes, and always technology advances are the main drivers for this development in rural settings. And but what happens most of the times is the policy choices we make which determines the benefits. I mean, to which class of society will be able to reap the benefits of this particular technology interventions. Uh, uh, can you see the next slide? Hello?
This is the larger economy slide is still there.
Oh,
Now
yeah.
it,
Can you
it
see
came.
now?
Yeah, it came.
Yeah. Okay. Yeah. So I mean, so at times what happens basically, since the RUTAG is housed at IIT Madras, being an academic institute, most of the times we develop these technologies with a particular group. I mean, which specifically mentions about their need, especially in a particular sector. Then what we do is we aggregate various resources, faculty, research teams, and funding, and some experts from the industry, and then we try to develop a solution for that problem. And then what happens most of the times, actually, when you go down to a particular other regions down the line, maybe 50 kilometers away, then automatically the needs are different, because the ecosystem changes, and the stakeholders changes, and their needs are different. So there are this spatial changes, geographical changes, and again at times the technology becomes obsolete. I mean, you develop with a particular intention, with a particular value of proposition in mind, but later after down the line 5 years, I mean, you may feel that this technology is no more required. I mean, there are some changes already happened in the place. So in that case, actually you have to deal with this kind of issues, like how technology is playing a important role in that ecosystem. And also when you look at technology, affordability, access, and everything, you have to deal with dynamics of this technology in that ecosystem, how technology is playing with different stakeholders, and how stakeholders are interacting with each and everyone in the ecosystem, and how the entire business model is working around. So that all needs to be looked at, that specifically product market fit. So the product which is good for one particular market may not be good for another market. So that you have to basically look at. And again, coming to technology dissemination, sometimes although we make technologies with a particular interest and with a particular class of society in mind, and local capabilities to manufacture and scale it up is also a challenging issue. So sometimes you don't find many fabricators or many people who are interested to take this up as a business case. You may not be able to find. So that again is a challenge. So as a technology developing institution, we most of the times we face these kind of issues. And also linkages with schemes. I mean, the government is supporting with a lot of schemes, so which can be related to end users of that particular technology, or maybe it is related to sector. I mean, especially to give an example, the Mahila Kaya Yojana in India is specifically tries to provide incentives and subsidies for women entrepreneurs or women labor force in this choir sector. So we have to link these particular end users with different schemes, so that it becomes a larger success. And also importantly, policy choices we make. I mean, what kind of policy support mechanisms are there, and different funding mechanisms to support these kind of initiatives definitely will take all of us to a greater success, especially in terms of technology dissemination. So with this, I would like to stop my presentation, and thank you for everyone.
Okay. So thank you, Srinivas.
Yeah, thank you, sir.
So at this point, are there any questions? So the questions could be broadly either for Rural Technology Action Group, or to Professor Shankar Krishna Pillai for the case studies that he wonderfully presented, and to Srinivas, who spoke about challenges in dissemination. So if not, I think it's quite late in the day. So we've had 2 hours of program so far. So Ujjwala, shall we wind up then? Anyway, I'm sure all our details and some of our presentations will be shared with the participants. And so if they have questions, they can always come back to us and we can continue the dialogue ahead.
Make a small comment, please.
Sure, sure. Please go ahead.
Okay, Professor Abhijit.
Dr. Dayal, your voice is not audible.
Yeah,
it's not audible.
No, now it's audible.
Is
again.
it audible now?
Yes, yes.
Okay, okay. Now I just wanted to make one small submission. Kind of a technology, giving a presentation, sir.
Sir, your voice is breaking.
In this platform also, African countries particularly.
There was some break in your voice. Could you please repeat?
Dr. Dayal, if the technology issue persists,
is it still breaking?
Window.
Yeah, Dr. Dayal, actually, we were not able to hear you. Maybe you'll have to repeat.
Am I audible?
No?
No?
Yes, you're audible now.
Okay, what I was suggesting, Professor Abhijit, am I audible, sir? Am I audible?
Sir, there is some lack of some video clarity and voice.
Yeah.
So please, we request you to post it in the chat window so that we don't.
I'll post it later. Okay,
Yeah,
okay,
yeah,
okay,
yeah.
okay. Thank you very much.
Yeah. Is it a suggestion for
yeah, it is a
program,
suggestion.
Tomorrow onwards?
Yes, it is a suggestion.
Okay. Yeah, so
I'll post it also.
Ujjwala will be in touch with you to take it forward.
Right, Professor. Right, Professor. Abhijit.
Yeah.
Thank you very much.
Okay, then.
Hello, sir.
Yeah, sure.
That's better, right? Better. Right. So that to me, no, I was asking yesterday.
Hello, do we have a question?
I have a question.
Yes, please go ahead. Please go ahead.
Yeah. First of all, I would like to say thank you for all people that participate in this amazing lecture. Regarding the points of the economic, you have the good product for the math, and this can be make an exhibition in Sudan or in Africa specifically, because this open market here, and you can we can exchange our goods, and it will be like a cooperation between us and Indian country, Asian countries. So we can organize exhibition in my country or in other country. Just we can do that, and we can help the production to be developed. I think that. Thank you.
Yes, thank you very much. That's an excellent idea, and our Global Engagement Office will be in touch with you to put together, how this can be taken forward. Thank you very much for the suggestion. Any other comments or questions? Okay, then I think Ujjwala, we can wind up for the day, I think, and so I hand it over to you. Thank you.
Thank you, Professor Abhijit, and thank you, Professor Shankar Krishna Pillai. Thank you for enriching all the participants with your valuable demonstration and suggestion of the technologies. The Q&A section has been very interactive with a lot of questions, and a lot of participants have been very appreciative of the technology shared today. With this, I also want to thank Mr. Kamal Dhameja, Technical Officer at the IEC Division of AARDO, Dr. Rajeshwar Dayal, Head of the IEC Division at AARDO, and Mr. Anwar, Head of the PPP Division at AARDO. Thank you, everyone. Thank you very much for being present and making this session very interactive and lively. We look forward for the session tomorrow, and we are going to have technologies enhancing productivity of small farmers. That's a topic for tomorrow. The speakers for tomorrow are Professor Satyanarayan R. Chakravarti, Professor at Department of Aerospace Engineering, IIT Madras, followed by Professor Sridhar Kumar Narasimhan, Professor at the Department of Chemical Engineering, IIT Madras. The session will be moderated by Dr. Palaniappan Ramu, Associate Professor in the Department of Engineering Design at IIT Madras. With this, we wish you all at different time zones very happy rest of the day or night, and thank you.